Hi, good evening, dear all. Welcome to another session of live session of physics from brilliant Qatar. We have one more day tomorrow for the last round preparation. So we are in the last session. Hope your preparations are going well. In today's session, we are going to discuss 4 important chapters. You know which are the chapters we are going to discuss today. Electromagnetic induction, alternating current, ray optics and wave optics. Chapters with maximum weightages. All topics are important, so I'll try to cover all the topics which are there in this year's syllabus in this session. So I'm expecting your kind attention and quick response for the questions. So without wasting time, I'm going to start the discussion. First chapter we are going to discuss today is electromagnetic induction, EMI. In EMI, we will first quickly go through the important topic. The first one is magnetic flux. Magnetic flux questions will be there. Direct question you can expect. Numerical also will come. First one is, what is magnetic flux? What is the definition? You know that magnetic flux is the total number of field lines passing normal to a surface, passing perpendicular to a surface. I hope the definition is clear for all of you. Now, what is the formula for calculating magnetic flux? That's the next thing. Flux formula. You know that if there is a magnetic field of intensity B, and you can see the direction, it is from left to right, and it is passing through an area. This is the area, and you can see that that area is not perpendicular to the magnetic field. If you are taking the magnitude of that area is A, then the formula for magnetic flux phi is equal to BA cos theta. BA cos theta is the formula for the magnetic flux. Here B is the intensity of magnetic field, A is the area, and theta. This is one area where students are making mistake while taking the value of theta. Especially, my dear students, when you are doing MCQs, be careful about the value of theta. What is theta in this case? You know that this is a dot product. BA cos theta is B dot A, which means vector B dot vector A. That means both B and A are vectors. And surely this theta is the angle between vector B and vector A. Vector B, from the diagram you can see it is towards right. What is the direction of vector A? Vector A is perpendicular to the area. This is vector A, so this angle is what? Theta. Please be careful. In some question they will give that plane of the coil or plane of the, whichever is the area, plane is perpendicular to the magnetic field. In the question you can see the word perpendicular. My dear students, please don't take theta as 90. Plane is perpendicular means area vector will be parallel to the magnetic field. You have to take the angle between area vector and magnetic field. Please be careful about that. So this is the formula for magnetic flux. Please note the unit of magnetic flux. It is Weber, you know that, or it is Tesla meter square, and there may be question with more turns. So this is the flux of one turn. If there are 2 turns, it will be 2 BA cos theta. 3 turns, it will be 3 BA cos theta. And if there are n turns, the formula will be n BA cos theta. I hope the first topic, that means magnetic flux part, is very clear for you. I'm going to the next topic. The next topic is another important one. Faraday's laws of electromagnetic induction. Direct question may be there. State Faraday's law. How many laws are there? 2 laws, right? First law of EMI, second law of EMI. First law is the definition of electromagnetic induction itself. What is it? What is EMI? Chance is there. Whenever the magnetic flux linked with a closed circuit changes, an EMF is induced. This phenomenon is called electromagnetic induction. Second law, the most important one, about magnitude of induced EMF. How much EMF will be produced? You know that according to Faraday's second law, magnitude of induced EMF is equal to, or it is directly proportional to, the rate of change of magnetic flux. Rate of change, d phi by dt, very important formula. And you know that there is a negative sign. What is the meaning of the negative sign? Negative sign indicate that the direction of EMF, it is actually from Lenz's law. That we will discuss separately. Anyway, when we are doing numerical also, put that negative sign. E is equal to minus d phi by dt. I hope this topic is also clear for all of you. So we started with magnetic flux. Clear? Now Faraday's laws of electromagnetic induction. Study the statement and the formula. Next. Lenz's law. Very, very important topic. In almost, if you are checking the last 5-10 years paper, in almost all the papers you can see one question from Lenz's law to find the direction of induced current or induced EMF. statement. Normally the chance of asking statement is very less, but anyway you have to study the statement. It's a very small statement. What is the statement of Lenz's law? The direction of induced EMF is such that it opposes the cause which produces it. Whichever is the cause that is producing EMF, the EMF will try to oppose the same cause. This is the statement of what? Lenz's law. Okay, so and actually because of that only in your previous formula, like electromagnetic induction formula, there is a negative sign. So study the statement. And some other question which they are asking, theoretical question from Lenz's law is, Lenz's law is an example for the law of conservation of energy, especially law of conservation of mechanical energy, justify. So the justification for that is, you know that it is based on the production of current, electricity. So we are producing electrical energy by the movement of the magnet. So movement of the magnet is which energy? It is mechanical energy. So mechanical energy is converted into what? Electrical energy. That's what the process happening in electromagnetic induction. But how can we give it as a justification for energy conservation in Lenz's law? Question came for board exam also. The answer is, according to Lenz's law, there is an opposing force. If there is an opposing force, to move the magnet we have to do work. That work done, the work done against the opposing force, the mechanical work done against the opposing force is converted into what? Electrical energy. That is the explanation for that. Now let's go to some questions based on Lenz's law. Many type of questions are there, variety of questions are there. We don't have time to discuss all the questions. Let's check some question here. A bar magnet is moved in the direction indicated by the arrow between the two coils PQ and CD. So there are two coils, you can see PQ and CD. Predict the direction of induced current in each coil. Before answering this question, you should have some idea about the polarity of a coil. How to determine the polarity of a current carrying coil. I think all of you know that. In a current carrying coil or a solenoid, there are two choices like north pole and south pole. So the question is, which side is the north pole and which side is what? The south pole. How can you determine that? Very simple. You know that the shape we are looking to a closed loop. If current is passing through it, we have two choices for the direction of current. It will be either, the current can be either in clockwise direction or it will be in what? Anti-clockwise direction. So if current is flowing in, if this is a loop, if current is flowing in clockwise direction, if you're looking from the front side, if the current is flowing in clockwise direction, that end will be the south pole of that coil. All of you know that. And at the same time, if current is flowing in anti-clockwise, anti-clockwise means like this, that end will be behaving like what? North pole. So please keep this idea in your mind before going to the questions based on Lenz's law. Now look at this. What is happening? You can see there are two coils PQ and CD. In between the coil there is a magnet, north and south. And this magnet is moving from which side to which side? It is, you can see the arrow mark is showing it is moving from left to right. Then what are the directions of induced current? In this question there is a small, you can see there is a confusion about the way of winding of the coil. We are not clear because it's a small diagram and they did not show the road over which the coil is wound. So if such a confusion is there, when you are writing the answer, you have to be very careful. Look, what is happening here once again? This is the north pole and this is the south pole of the magnet. Okay, magnet is moving. For when we are considering the coil, first coil, the coil PQ, concentrate only on the coil PQ. What is happening for magnetic field related to PQ? You can see the magnet is going away from it. There is a coil PQ which is fixed, but the magnet is going away from it, isn't it? According to Lenz's law, the direction of induced EMF is such that it opposes the cause. So my dear students, please think, what is the cause of EMF here? Answer is very simple. The cause of EMF is magnet is moving away. The away movement of the magnet is the cause of EMF in this case. So according to Lenz's law, the induced EMF will try to oppose the cause. What is the cause once again? Magnet is going away. So induced EMF will try to oppose the cause means induced EMF will try to pull it back. Isn't it? It will try to pull it back, which means when current is passing through the coil PQ, all of you know that it's a solenoid, it will behave like a magnet. Every magnet has two poles. So idea is very simple. Quickly answer to my question. Q side, the side Q should behave like which pole? That's what you have to answer me. The side Q should behave like which pole to pull the magnet back? Yes, it should behave like south pole, because only south can attract north. So that is behaving like south pole, and this side will be behaving like what? North pole. That's it. And after that you can write, while writing the answer, what you have to write is the end Q will be behaving like the south pole, and therefore the current in that end will be in clockwise direction. Clockwise direction. Okay. And so I think a PQ part is very clear for you. Go to CD. For CD, what is happening? For CD, you can see magnet is going towards the coil CD, right? Magnet is going towards CD. Okay, what is the cause of EMF? Magnet is coming towards it. So according to Lenz's law, it will try to oppose the cause. What is the cause here? Magnet is coming towards it. It will try to oppose it. Opposition. This is south pole. So that south pole should be opposed by the side C. Tell me, C should behave like which pole again? Yes, it should also behave like what? South, because south only can oppose south. That means if you are looking from the end C, again the current in that end will also be in what? Clockwise direction. Clockwise direction. Okay, this idea is not only applicable for this question. If any question comes like the movement of magnet, this is the idea you have to use. I hope it is very clear for you. Yes, I can see many comments. Very good. All are doing well. I'm going to the next question. Yes, this is another type of question which always you can see. Two loops of different shapes are moved in a region of uniform magnetic field in the direction marked by arrows as shown in the figure. Okay, in this case you have to find the direction of induced currents in the loops A, B, C, and this G, F, E, D. That's the second loop. Here there is a fundamental, like basic idea, you know that if there is a cross mark to represent a field, that cross mark is indicating the field is directed into the plane of the paper, into the plane of the board. Okay, so here what you can see in this diagram is there is a uniform magnetic field. The spacing is same, so there is a uniform magnetic field, and the coil ABC, you can see some part of that ABC is out of the field, outside the field, and arrow mark is in, which means the coil ABC is going towards the field. It was initially outside, it's going inside, but at the same time the other one, it is going out. So that's the difference. This one is in and this is out. Okay, so what is the idea here? If a coil is out, just think ABC, it is outside. What is the flux linked with that coil? If outside the magnetic field, flux will be zero. It is going towards the magnetic field, towards the magnetic field. So if you think about its flux only, because Faraday said change in flux only is producing EMF. So initially it is out, no flux, it is coming towards the field, into the field. So what will happen to the flux? Easy, flux is increasing, isn't it? Flux is increasing. That is the cause. So what is the cause of EMF for the first coil? It is the increase in flux. My dear students, increase in flux is the reason for what? EMF. So EMF will try to oppose the cause. Yes, what is the cause? Flux is increasing. So EMF will try to decrease it. How is that possible? That's what you have to check. We need to decrease the flux. Already there is a field. Already there is a flux. In which direction? Inward. Flux is inward. We have to decrease that. You just assume there is 100 flux inward and we need to decrease it. How is that possible? If you can produce some flux outside, for example 50 flux outside, so total flux will be 100 minus 50. Understood or not? That is the point for this question. Reason for inducing EMF in coil ABC is flux is increasing. Induced EMF will try to oppose it. For that we should try to decrease the present flux. We need a new flux opposite to the direction of the present flux. That means the induced current in ABC, please note that the induced current in ABC should flow in such a way that a new magnetic field should be created opposite to the direction of the existing flux. Existing flux is inward, opposite to the direction of existing flux. That means outward. Very simple, my dear students. Take your right hand, keep it like this and keep the thumb outside. Thumb outside. Check your closed fingers. What is the direction of closed fingers? Clockwise or anti-clockwise? Clearly you can see that it is anti-clockwise, very simple. So the direction of current induced in the coil ABC is in anti-clockwise direction. Clear or not? I think it's okay for you. So you have to keep your thumb of right hand in the direction of the new magnetic field. Okay, so anti-clockwise. So the direction of induced current in this coil is anti-clockwise. Come to, now I think the second one you can easily do. For the second one, what is happening? It is in the field now. It is in the magnetic field and it's going out. Think about it, it is going out. When it is going out, what will happen to the flux? The flux is decreasing. The flux is decreasing. So the EMF will try to increase the flux. How can we increase the flux? Already there is a flux. In which direction? Inward. We are trying to increase it, which means we need a new flux in the direction of the present flux. What is the direction of the present flux? Inward. New flux should also be inward. Take the thumb of right hand pointing into the plane of the paper. My dear students, you can see that it is clockwise. So the direction of induced current in it is clockwise. I think it's clear for all of you. Please comment. Yes. I'm getting many responses. Very good. This is also clear, I think. So I'm going to the next question. Time is not there, that's why we are going quickly. Look at the third. This is another type of question from Lenz's law. A conducting loop is held below a current carrying wire PQ as shown in figure. There is a conducting loop PQ. You can see the current is going from left to right in this. Predict the direction of the induced current in the loop when the current in the wire is constantly increasing. What you have to note about this question is, in using the same diagram, they can make variety of questions. How? Like they can change the direction of current. In this diagram you can see current is from left to right. You have to read your question carefully. Make sure that in which way the current is flowing. If it is left towards left, the answer will be different. And here it is given that constantly increasing. In your question it may be constantly decreasing, and in some question it can be a steady current. So please be careful. Okay, I'll tell you a general idea how to find it. First step is, see, we have to find the direction of induced current in the circular coil. Okay, first step is, if there is a straight wire which is carrying current, surely there will be a magnetic field around it. We know that a current carrying wire will be producing what? A magnetic field. First step is finding the direction of that magnetic field. Yes. How? Thumb rule. Okay, so just apply thumb rule in exam hall. There is no problem. No need to worry about the examiner while applying the hand rules and all. You may have to turn here and there. No issue. You can use it. Okay, so if you are applying the thumb rule, on the top, you can see that my toes fingers are like it is coming out. So on the top, the field is coming out, and bottom it's going in, which means below the conductor, the magnetic field is directed into the plane of the board or into the plane of the paper. That's the first step, finding the direction of magnetic field produced by this current carrying wire. I think this part is very clear. Now think, read the question carefully. Current in the wire is constantly increasing. So when current increases, think about it. When current increases, what will happen to the field? Surely when current increases, field will also increase. Field increases means flux is also increasing, not the point. What is the cause of EMF? Flux is increasing. Cause of EMF is increase in flux. Now the things are easy. EMF will try to decrease the flux. What's the direction of present flux? Inward. To decrease it, we need a new flux? Outward. Take your thumb again, pointing it out. Tell me the answer. Clockwise or anti-clockwise? Anti-clockwise. Yes, I can see the answers. Very good. Anti-clockwise. So the direction of induced current is anti-clockwise. Okay, right. I think you got the basic idea of Lenz's law. So please practice the questions with you and try to find all the answers of these kind of questions by yourself. Okay, so I'm going to the next topic, motional EMF. Motional EMF, another important topic. There may be numericals also from it. What is motional EMF? Definition, very simple. It is a special case of electromagnetic induction. It is the EMF induced in a conductor due to its motion in a magnetic field. When a metallic wire, a piece of wire, a conductor is moving in a magnetic field, due to the motion, EMF will be produced. That EMF is called what? Motional EMF. And the formula for motional EMF is E is equal to what? BLV. B is the magnetic field, L is the length of the conductor which is moving, and V is the velocity of the conductor. So this is the formula for what? Motional EMF. But when we are studying this formula, please note that This formula is applicable only when the velocity is perpendicular to the magnetic field. Perpendicular to the magnetic field only we have to use BLV in a question. If it is giving that there is some angle like velocity and magnetic field are at 30 degree or something, add a term sine theta with it, then you'll get easily BLV sine theta. Okay, so BLV sine theta you can think. So if theta is 90, what happens? Sine 90 is how much? 1. So you get BLV. If instead of 90, if it is not perpendicular, it is given that it is 30 degree, 60 degree, substitute that value and do it. Is it okay? Now there is a special case of motional EMF. That also you can see if you're checking the past year paper. You can see that question also, like here V is what? V is the linear velocity. You know that V is simply velocity means it is a linear velocity, which means the conductor is moving like this, translatory motion. At the same time, if a conductor is rotating in a magnetic field, rotational motion also can produce what? An EMF. So that also, that formula also you have to by heart. In some question you can see the derivation also been asked. Please go to that derivation. E is equal to both the derivation, motional EMF this one and rotational one. The formula only I am writing here, half B L square omega. Okay, this is the expression for what? The EMF induced in a rotating conductor. Okay, again L is the length and what is omega? You can see omega standard representation for angular frequency or angular velocity. Okay, and please note that if they're asking EMF only, you have to use this formula. They may ask current, this divided by the resistance R. Okay, so basic formulas, power, everything you know, so just substitute and find it. This is for the EMF. EMF means voltage. Okay, so these are the two basic formula which you have to study about motional EMF. And another thing, please keep it in your mind, right hand, Fleming's right hand rule for finding the direction of induced current in motional EMF. Okay, Fleming's right hand rule, very simple. You are all familiar with the left hand rule. In right hand rule, you know that forefinger indicate magnetic field, thumb indicate the direction of motion, and the middle finger will give you the direction of current. You're familiar with it. Okay, so that's all about motional EMF. There is a question, check that. It's a question from motional EMF. A jet plane traveling west at 450 meters per second. If the vertical component of Earth's magnetic field at that place is 4 into 10 raised to minus 4 Tesla, find the EMF induced between the ends of wings having a span of 30 meter. 30 meter. Don't be confused by seeing this kind of question. It's very easy. Check. A jet plane traveling west. So it is traveling in west direction. So horizontally from west, I mean east to west, like that it is traveling at a speed. So speed is given. If the vertical component, not that, vertical component of Earth's magnetic field. So traveling towards west means horizontally. Vertical component of Earth's magnetic field. So no doubt vertical component means that magnetic field and the velocity. What will be the angle between them? 90 degree only. Okay. Tesla is given and EMF induced between the ends of the wings. The length of the wings is given 30, which means speed is equal to 450 meter per second. Magnetic field B value is 4 into 10 to the power minus 4 Tesla. Length of the conductor is 30 meter. Yes, directly you can use the formula, isn't it? Yes, E is equal to BLV. Substitute. I am not going to made the calculation here. It's only because of we don't have time. We have 4 chapters to be completed. And just explaining the idea. Calculation part I am leaving to you. Just substitute because you have to practice the manual calculation, right? Okay, I think already some students comment the answer. 5.4 something. I think it's correct only. 5.4 volt. You can check it. Okay, so I'm going to the next question. Yes, look at this. A square loop of side 10 centimeter and resistance 0.5 ohm is placed vertically in east-west plane. A uniform magnetic field of 0.10 Tesla is set up across the plane in the northeast direction. The magnetic field is decreased to 0 in 0.7 seconds at a steady rate. Determine the magnitude of induced EMF and current during this time interval. This one is a bit confusing, bit lengthy, but no need to worry. You just read the question carefully. Develop an idea. Okay, first let us write the given data. There is a square loop. Okay, there is a square loop. It is a square loop. Side. So side is 10 centimeter given. Resistance also is given. R is equal to, I am writing R is equal to how many ohm? 0.5 ohm is the resistance. Okay. Placed vertically in east-west plane. So just bring that idea in your mind. You can take east on left side and west on. So it is in the east, vertically in east-west plane. So like this. Okay, we are placing the coil like this. A uniform magnetic field of, so magnetic field value is given 0.10 Tesla is set up across the plane in northeast direction. Northeast direction. Northeast. So remember, this is in what? East-west. And the other one is, and so it is a bit confusing. So I'm just marking here the poles, west, east, north, south. Okay, sorry, it is in the other way. North, south. Where is a plane? Plane is kept in east-west. So this is a plane. And magnetic field is set up across the plane in northeast. Northeast means it has to be like this. Please note that. Northeast direction. Okay? Yeah. There is a doubt. Previous plane has 2 wings. Vigneshwaran is asking. They did not mention like that. No, the total wings length only you can take. Vignesh. Okay. Span means they did not say one wings is having this much of length. So you can take like that. Okay. Listen. So look at this. So this is the direction of what? Magnetic field. Which means northeast means what is the value? This angle. It is through the middle. Middle means 45 degree. That's an important point. If you're not considering that, our answer will be wrong. 45 degree. Okay. And next point is the magnetic field decreased to 0 in 0.70 second. Decreased to 0. Magnetic field is decreased to 0. So field is changing in 0.70 second at a steady rate. Determine the magnitude of induced EMF and current. Okay. What is the formula for EMF? This is not a question directly from motional EMF. So many datas are there. B is there. Loop is there. Go to Faraday's law. E is equal to what? EMF is equal to minus d phi by dt. My dear students, what is d phi? D phi is change in flux. Change in flux. So here they did not give any value for change in flux. So it's our duty. We have to find. Check. Flux depends on. What is the formula for flux? So I'm just writing d phi is change in flux. So minus d by dt of, what is the formula for flux? NBA cos theta. NBA cos theta, isn't it? N, number of turns. They did not say anything about number of turns. Leave it, you can take it as 1. B is given. Area of square loop that you can find. Area is equal to 10 centimeter. 0.1 meter square. 0.01 meter square will be the area. Area of the square loop. 0.01 meter square. Okay. B. Now you have to check for there is change in flux. Anything out of this 4 term should change. Either N should change, B, A, cos theta. In this question, which one is changing? Which quantity is changing? In this question, it is not same for all the question. You have to read the question carefully. In this question, the quantity which is changing is what? Magnetic field. So other thing you can take out. N will come out. N is 1 anyway. Leave it. Area will come out. Cos theta. Theta value is 45. That will also come out. Cos 45. B is changing. Change in magnetic field is, it is given. It is changed to 0. From how much? 0.10. So you know that basically changes final minus initial. So finally 0 minus initial is how much? 0.1. Minus is here. Divided by. Time is given. Time is 0.70 second. You can substitute the data. You will get the answer. Okay. Here there is a minus. Minus and minus will be cancelled. Will become positive. Okay. Yes. Do the calculation by yourself. So I'll be going to the next. Please note. I think it's clear for all of you. Next question. Next topic, self-induction. Self-induction, important topic. Self-induction. First, what is definition of self-induction? Self-induction is, you know that, it is the phenomenon by which an EMF is induced in the same coil whenever the magnetic flux linked with that coil changes. Yes, Razil. It's a previous year question, past year question only. Okay. Listen. Self-induction. So the phenomenon of inducing back EMF in a coil is also known as what? Self-induction. So there are some formula which you have to study. Right. First one is about self-inductance. You know that flux linked with a coil is directly proportional to the current. Phi is proportional to I. Phi is equal to a constant into I, where L is a constant called what? Self-inductance. Okay. One formula. Then EMF induced is minus L into what? Di by dt, where di by dt is the rate of change of current. Rate of change of current. Okay. Yeah. Minus L into di by dt. This is, then another formula is expression for self-inductance of a solenoid, mu naught n square L, one formula. And there is another formula, don't be confused, mu naught n square A by L. A by L. Okay, what is the difference between small n and capital N? Capital N is the, see, please note that in magnetism standard notations are there. Small n is representing number of turns per unit length and capital N is representing total number of turns. Okay, and another point which you have to note about the self-inductance part is, here you can see mu naught, which means the region, the space inside the solenoid is free space. If there is a medium, we should change the formula. L will become mu naught mu r n square L, where mu r, all of you know, it is a relative permeability. Okay, yes, I think this part is very clear for you. Next, there is a question from self-inductance, repeating type. Look at this. Current in a circuit is steadily changing from 2.6 ampere to 0.6 ampere in 10 milliseconds if an average EM of 266 volt is induced. Calculate the self-inductance. Direct question only. What you have to do is just recall the formula and substitute. Check. Current is changing from 2.6 to 0.6. Current is changing. Change in current you can easily find. So change in current you can represent it by what? DI. DI is final minus initial, 0.6 minus 2.6. So you get minus 2 ampere is a change in current. Time is given, EMF is also given. So which formula relates these quantities? It is E is equal to minus L into di by dt. All quantities are given except self-inductance value that you can easily find from this. So di is minus 2. So substitute, EMF is 266 minus L and minus 2. So it will become plus. So L into 2 by time is how much? 10 milliseconds. So 10 into 10 raised to minus 3 millisecond you should convert into seconds. So you can easily find the value of self-inductance. I think it's also fine for you. I'm going to the next question. Calculation you can do. Next. Energy stored in an inductor derivation is also important. Okay. Energy stored in an inductor. What is the formula? U is equal to, a current carrying inductor stores some energy in it, and the formula for that is half Li square. Half Li square is the formula for what? Energy stored. And what is the expression for the energy density? You know what is energy density? Is energy per unit volume. It is half or B square by 2 mu naught. This is for energy density. Energy density is energy per unit volume. So please study both the derivations. Okay. Next topic, mutual induction. You're okay with self-induction? Sorry. What is mutual induction? Whenever the magnetic flux, yeah, energy density is energy by volume. Whenever the magnetic flux linked with a coil changes, EMF is induced in the neighboring coil. This phenomenon is called what? Mutual induction. So we have formula for mutual inductance. M is equal to phi 2 by I1. One formula. This is M21. Mutual inductance of second coil with respect to first coil. And then if you're writing M12, it will be phi 1 by I2. So what is the difference between self-inductance formula and mutual inductance formula? In self-inductance, both current and magnetic flux, we are taking the same coil, but here current is in one coil and flux is in the other coils. That's the reason why phi 2 by I1. Phi 2 is the flux in second coil, I1 is the current in first coil. Hope you understand. And then other formula. Generally you can write M is equal to phi by I. So what is the point you have to note here is, in this formula also, phi is a flux linked with one coil and I is a current in the other coil. Okay, right. So EMF is equal to minus M into di by dt. In self-inductance the formula was L into di by dt. Here we have M into di by dt. Okay, then what is the formula for the mutual inductance? That depends. That depends on the nature of the coil, number of turns of the coil. So many different questions are there to derive expression for mutual inductance of one coil with respect to another coil. Those questions also you have to practice how to find mutual inductance. Idea is easy. First you have to take current in one coil, find the flux of the other coil, give current in one coil, it will produce some magnetic field in the other coil, and find the flux of that coil, and then take phi by I. We know the formula for M is phi by I. Okay, I think it's clear now. Yeah. Next, there is a question from mutual inductance. Quickly, a pair of adjacent coil has a mutual inductance of 1.5 Henry. So 1.5 Henry is a mutual inductance value. Henry. If the current in one coil changes from 0 to 20 ampere in 0.5 seconds, what is the change in flux? Please note, here they are not asking the EMF. The question is to find what? Change in flux. Only change in flux. Link with the coil. So how can we find here? Mutual inductance is given. Change in current di is 0 to 20 ampere. So change in current di will be what? 20 only. Okay, we have to find change in flux. So what is the formula with us? E is equal to minus M into di by dt. Minus M into di by dt. Okay, E is, we know that it is minus d phi by dt equal to what? Minus M into di by dt. Why we are writing like this? Because they are asking to find the change in flux. So dt will be cancelled. Minus minus, leave it. So look at the result. D phi is equal to what? M into di. M into di. You can easily find the answer. What is M value? M is given 1.5 Henry. Di is 20. We got the answer. Look at this. It is 3. 3 Weber. Don't forget to write the unit. Change in flux is 3 Weber. Is it okay? Yeah. So I'm going to the next question. I think this is also fine. So my dear students, probable questions from self-induction and mutual induction, these type of questions will come. I'm going to the next. AC generator. AC generator is, they can ask it for 5 mark also with an additional numerical question. What is an AC generator? What is its working principle? Explain its construction and working. Okay. First, what is an AC generator? What is the answer for that? It is a device which converts mechanical energy to what? Electrical energy. Mechanical energy to electrical energy. Working principle is what? AC generator, electromagnetic induction. Then working. Working means you have to show the magnetic field, armature coil, the rotation, and finally you have to derive the equation for EMF induced. What is the equation? E is equal to, yes, NBA omega into sin omega t. Okay, NBA omega sin omega t. Okay, 1 second. Is there any mistake in the previous question? Yeah, so the last answer is 30. It is not 3, it is 30. 15 into 2, right? Okay, thanks. Yeah, listen. So E is equal to NBA omega sin omega t. This is the expression for what? The EMF. And show the graphical representation of alternating current also. Based on the mark only you have to write the answer. Okay, yes. Here, what is N? N is the number of turns, B is the magnetic field, A is the area, and omega is the angular velocity of the coil. T is the time. So this is representing the instantaneous voltage, and you know that this part of the formula is a constant. NBA omega is a constant. Only variable is what? Time. and the maximum value of the sine function, maximum value is 1. When that sine function is 1, we get E is equal to NBA omega. That is the maximum possible value, that is represented by E naught. So the formula for E is E naught sine omega t, and this divided by resistance will give you the current, I equal to I naught sine omega t. Okay, yes, very good. So I'm going to the next. So AC generator, please study that. Okay, you can easily score mark from it. Question, look at this. A circular coil of radius 8 centimeter. Radius, let's quickly write. Radius is 8 centimeter. Okay, 8 centimeter. And 20 turns. So number of turns is given as 20. Is rotated about its vertical diameter with an angular speed of 50 radian per second. So omega is given 50 radian per second, SI unit only. No need to make any change. In a uniform horizontal magnetic field of magnitude, B value is given 3 into 10 to the power minus 2 Tesla. Obtain the maximum and average EMF induced in the coil. Maximum and average. Average I will tell you. So let us find the maximum value. If the coil forms a closed loop of resistance 10 ohm, calculate the maximum value of current. So we have to find maximum EMF and maximum current. Which formula we will use? Maximum EMF, E naught is equal to NBA omega. Maximum EMF. Maximum current, I naught is E naught by R. Everything is there in the question. There is no confusion. N is 20. B is given 3 into 10 raised to minus 2. Area you have to calculate. It's a circular coil. Radius is given. So using that radius you can calculate the area. Omega is directly given 50. Substitute. Resistance is there. So you can, what is the resistance value? 10 ohm. So everything you can substitute. You can do the calculation by yourself. Okay. You know the reason why I'm not going to the calculation part means we don't have time. Okay. Next, and one more thing. Here they are asking maximum value of EMF and maximum value of current. We got the answers, but there is a question related to average. Average part, anyway, we will discuss in our next chapter. At that time I will tell you how to find average. Most of you may be knowing the answer. So I'm going to the next. Yeah. Now we are starting our next chapter. Alternating current, AC. Okay. Very important chapter. Many concepts are there. Quickly let's go to it. Equation for alternating voltage and alternating current. Already we discussed it. Tell me, what is the equation for voltage? E equal to E naught sine omega t, or we can use V also. Any notation is fine. So V equal to V naught sine omega t. So when you are writing this formula, please note that what is the value of V naught? V naught is NBA omega. NBA omega. This is the equation for alternating voltage and alternating current. I equal to what? I naught sine omega t. Where I naught is E naught by R. E naught by R, which means NBA omega by R. This is I naught value. Okay. And graphical representation also, please note that in one complete cycle we'll get like this: 0, 90 degree. That means pi by 2, pi, 3 pi by 2, and finally 2 pi, right? This is the variation of voltage and current. Okay, so I think that part is very clear. Next, average value and RMS value. In many numerical you can see what is the average value, what is the RMS value. Okay, so what is the formula for average value of EMF? You know that V naught is representing what? The peak value. So if peak value is given, average value formula is, yes, V average is equal to, what is it? It is 2 V naught by pi. This is the formula for the average value. 2 V naught by pi, which is equal to, if you are calculating 2 by pi, you can see that it is 0.637 V naught. This is V average. Similarly, I average value of current will be 2 I naught by pi, which is equal to 0.637 I naught. 637 I naught. Okay, yes. This is average value, but at the same time, please note that in some question they will create confusion, especially in multiple choice part. They will give some data, V naught value and all, and the question will be the average value of AC for one complete cycle is. In one complete cycle, tell me, my dear students, what is the average value for one complete cycle? This average value is applicable only for what? Half cycle. This is the average value for half cycle. For one complete cycle, the average value will be 0 because there is positive and negative. It gets cancelled. Yes, very good. And next is RMS. You know that RMS is the equivalent DC, which means this is the effective value of AC. RMS is also called the effective value of AC. It is RMS means you know that it is root mean square. And what is the formula? It is easy. V0 by root 2. V0 by root 2. It is VRMS. It is equal to 0.707 V0. 0.707 V0. And IRMS is equal to I0 by root 2, which is equal to what? 0.707 I0. Average value of EMF and RMS value of EMF and current. Is it okay? Now in the previous question, I hope you remember there was a question to calculate the average value. So we found maximum, then maximum using this formula you can find average. See students, please make sure that you are answering to all the sub questions. It is one important point that I have been telling to my students always. You have to read the question carefully, each and every point in question, and make sure that you are answering to the question. I can see in many papers like students are missing some questions. It may be due to over excitement or tension. I don't know what is the reason, but in your exam hall, take your time, read each and every line carefully before submitting the paper. Okay, right. I'm going to the next. Yeah, the core part of this chapter. Okay, circuit, AC circuits. I'll quickly go through it. I think it's okay for all of you. We have 4 circuits in our syllabus. That means AC circuit containing resistor only, inductor only, capacitor only, and then series LCR circuit. Other circuit questions will also come like LR, CR, LC like that. But if you know LCR, other questions will be very easy. So what I need is, what is this? What we are studying in these circuits? We are studying only one thing. What is the relation between current and voltage? If you know the current and voltage, you can find the resistance of that circuit also. That's it. This is what we are studying. Okay, so first one. In a circuit, yeah, eddy current is not there. In a circuit containing resistor only, I'll start with the first. In all circuit, we can assume the voltage is V0 sin omega t. Voltage is V0 sin omega t. Quickly answer to my question. Resistor only circuit. What is the phase relation? What is the relation between current and voltage? All of you know. In a circuit containing resistor only, current and voltage are in same phase. Very good. Current and voltage are in same phase. What does it mean? What is the meaning of same phase? It doesn't mean that the magnitude of current is equal to magnitude of voltage. What is the meaning of same phase? If current and voltage are in same phase, the instant current reaches its maximum value, voltage will reach its maximum value. That's it. That means when current is maximum, voltage is maximum. Current is minimum, voltage is minimum. That's the meaning of what? Same phase. Yes. So in a circuit containing resistor only, current and voltage are in same phase, and in that circuit, what is the total resistance of the circuit? It's R only, just R. Total resistance of the circuit is R. Alright, second one is what? Inductor only. In our case, we are discussing ideal inductor. What is ideal inductor or pure inductor? An inductor without any resistance. Without any ohmic resistance is called what? Ideal inductor. In such a case, tell me the result. Who is leading? Current and voltage are not in same phase, right? Voltage is leading or current is lagging, which means in a circuit containing inductor only, the formula for current is I equal to I0 sin omega t minus pi by 2. Pi by 2 degree lagging. Current is lagging by pi by 2. Very good. And here there is another important point. What is the resistance offered by the circuit? You know that resistance is known as reactance, and it is a resistance offered by the inductor. It is called inductive reactance. What is the formula for inductive reactance? XL is equal to L omega. L omega, it's a frequency dependent reactance. How it is related to frequency? It is directly proportional. Yes, directly proportional. Very good. Okay. And they may ask you to draw the phasor diagram and graph. I think it's okay for all of you. What is phasor diagram? It's a vectorical representation between voltage and current to show the phase relation. Graph, graphical representation. So don't be confused. If they're asking graph, You have to draw graph only. That also a mistake the students are making. There is a question like, show graphically the phase relation between current and voltage in a circuit containing inductor only. So phase relation between current and voltage means you may think that it is a phasor diagram they are asking. No, show graphically means it's a graphical representation. Otherwise the question will be the phasor diagram they will specifically ask. Or if you have any confusion in that, do both. Graph and phasor diagram. So here what is a phasor diagram? How can you draw? Just simple way you can write, if this is current, voltage across the inductor is leading it by 90 degree. Okay, like that you can mark. Fine. Now the third circuit, what is it? Capacitor. Reverse of inductor, right? In a capacitor, in an inductor, voltage is leading. In capacitor, who is leading? Current is leading. So the formula for current will be, instead of minus, we'll be having what? Omega t plus pi by 2. Omega t plus pi by 2. Very good. Plus pi by 2. And what is the resistance offered by the capacitor? Capacitive reactance X is equal to what? 1 by C omega. 1 by C omega. Okay. And here you can see how reactance depends on frequency. They are inversely related, inversely proportional. Xc is inversely proportional to frequency, which means when frequency increases, capacitive reactance decreases. There is a question like, if you are connecting a capacitor across a battery, a cell, what is the frequency? 0. So if you are substituting 0 here, we get Xc as infinite. My dear students, note that a capacitor offers infinite resistance to the flow of DC. It blocks DC. It allows only AC to pass through it. Yes or no? Yes. So then phasor relation. Lagging. Current is leading, voltage is lagging. So VC can be like this. Okay. So that's all about the three basic circuit. I think it's very clear for you. In both inductor and capacitor, the phase relation is 90 degree. Phase relation between current and voltage is 90 degree. But the differences, in inductor, who is leading? Voltage is leading. In capacitor, current is leading. The phase difference is pi by 2. Okay. Then the third, series LCR circuit. In LCR circuit, who is leading, who is lagging? That depends. That depends on the value of VL and VC. So we have two formulas, two basic formulas in this circuit. What is it? One is for the impedance. What does mean by impedance? Impedance is the total resistance offered by the circuit, right? What is the formula for the impedance? Impedance of series LCR circuit, Z is equal to, students, without studying this formula, please don't go for the exam, okay? Z is equal to square root of R square plus XL minus XC the whole square. This is the formula for the impedance. Z is equal to root of R square plus XL minus XC the whole square. There is nothing wrong if you are writing it as XC minus XL, because anyway there is a square, it will be same. So root of R square plus XL minus XC the whole square is the formula for what? Impedance of a series LCR circuit. And what you have to note in this formula is, in this formula R is always fixed. R is always fixed, but XL and XC are variable because they are frequency dependent quantities. Okay, and the phase angle phi equal to phase relation between current and voltage. We have a formula. It is tan inverse of XL minus XC, divided by R. Tan inverse XL minus XC by R. This is the formula for what? Phase angle. So these two formulas you must study about what? A series LCR circuit. So please study all four circuits in detail. Now by chance in exam, if they are asking an LR circuit, that means inductor and resistor, what you have to do? No need to worry. They won't ask derivation of that. They will be asking numerical only. So LR circuit, for example, impedance of an LR circuit, what you have to do? In this formula, Z is equal to root of R square plus XL minus XC the whole square is there. So for LR circuit, cut the capacitor term. Remove XC, very good, remove that XC. So we will get what? Root of R square plus XL square. Okay, and for phi, remove XC. So we get XL by R only. Like that, if they are asking CR circuit, remove XL part. Hope it is clear for you. Right, so I am going to the next. Resonance, it's an important case of LCR circuit. Always chance is there for questions from this topic. Resonance, what does mean by resonance? Yes, what does mean by resonance? It's a condition, right? It's a condition of series LCR circuit at which the current is maximum. It is a condition at which the current in an LCR circuit is maximum. It is a condition at which the impedance is minimum. And how can you achieve this condition? Yes, very good. XL is equal to what? XC. This condition is called resonance. What is the meaning of XL is equal to XC? Inductive reactance is equal to capacitive reactance. X is equal to XC. That means L omega equal to 1 by Z omega. Then how can you achieve this condition? That also you can find from it. By solving these two equations, you get the frequency F is equal to 1 by 2 pi root LC. So at this frequency, resonance condition can be achieved, and because of that reason, this frequency is known as resonance frequency. Not this point. By heart this formula. Resonance frequency is equal to what? 1 by 2 pi root LC. And at resonance frequency, my dear students, please note that if XL equal to XC, what will be the value of impedance? What will be the value of impedance if XL is equal to XC? It will be equal to R, because XL and XC gets cancelled. Okay, which means at resonance condition, a series LCR circuit will be behaving like a pure resistive circuit. So like that also question can be asked. Under which condition a series LCR circuit will be behaving like a pure resistive circuit? Means the answer is at resonance. And if it is behaving like a pure resistive circuit, what is the phase relation between current and voltage? These are all probable multiple choice question. If it is behaving like a pure resistive circuit, what is the phase difference between current and voltage? Yeah. Yes, that's what Vignesh, that's what happening. Why it is called, what is the basic meaning of resonance? Hope you remember in 11th grade you had a topic called resonance. Resonance means frequency matching. The idea of frequency matching is resonance. So at XL is equal to XC, what is happening is the circuit has a natural frequency that becomes equal to the frequency of the applied voltage. They are becoming equal. Okay, that's why we are calling that condition as what? Resonance. Alright. Okay. So if Z is equal to R, phase value will be equal to, phase angle will be equal to 0. Okay, yes. So I think resonance part is very clear. Of course, Dhruvil, VL is equal to VC only. If XL is equal to XC, this is a series circuit, current is same. So if XL is equal to XC, if current is same, of course VL will be equal to VC. Okay. In LCR circuit, V, resultant voltage will be equal to VR square plus VL minus VC the whole square. From this only we are finding impedance equation. So if XL is equal to XC, VL is equal to what? VC. Okay, now in this resonance, you have to remember some graphs like between current and frequency. The shape of the graph will be like this, which means you can see the current is maximum at resonance frequency. And if they are asking you to draw the graph between impedance and frequency, it will be reverse of this. That means impedance is minimum at resonance frequency. Current is maximum at resonance frequency, impedance is minimum at resonance frequency. Yes. Okay. Listen. Dhruvil, I did not say. At resonance, VL is equal to VC. Okay, that's why it is behaving like VL is equal to VC. That's why it is behaving like what? A pure resistive circuit. Next. Question. Yeah, we are going to the questions now. A current, quickly we can go through it. A current flowing through a pure inductor of inductance 2 millihenry is I equal to 15 cos 300 t ampere. What is the RMS average value of current in complete cycle? Easily we can find. Look at this. If you are comparing the given equation with I equal to I naught cos omega t, what you can write from this, I naught is equal to 15. If I naught is equal to 15, RMS value, I RMS is equal to what? I naught by root 2. So 15 by root 2. Okay. And what about I average? Remember here in this question, please don't make mistake. They are asking average value over a complete cycle. Average value over a complete cycle. What is the answer for this? Average value over a complete cycle, quick. Yes, it is 0. Average value over a complete cycle is 0. Right. Going to the next question. It's an easy one. Next. A resistor of 400 ohm, an inductor of 5 by pi Henry, capacitor of 50 by pi microfarad are connected in series across a source of alternating voltage of 140 sine 100 pi t volts. Find the voltage. It is given RMS across the resistor, the inductor and capacitor. So it's a bit lengthy one. We have to find three things: voltage across resistor, voltage across inductor, and voltage across capacitor. And you can see that it's an LCR circuit. So let's draw it. LCR. Okay. Across a source of alternating voltage. So it is connected to an AC source. The source voltage is given as V equal to, look at that, 140 sine 100 pi t. Okay, this is the given voltage. Based on this formula, we have to find voltage across all the elements. That means this is the inductor, right? So we have to find V across inductor VL, V across capacitor VC, and V across resistor what? VR. How can you find these quantities? How can you find voltage? You know that voltage is equal to what? Current into resistance. So surely VL equal to what? I into resistance of that inductor. What is the formula? XL. XL means L omega. L omega. What about VC? VC is I into XC. That is 1 by C omega. And what about VR? Voltage across resistor. It will be current into R. Okay, now resistance is given in the question. Look, R is how many ohm? R is equal to 400 ohm. It is given in the question. R is 400. L omega and 1 by C omega we have to find. How? L omega. L is given as 5 by pi. 5 by pi. Omega, is it given? Directly you can't see omega value, but look at the formula. V equal to 140 sine 100 pi t. Compare with the standard equation for AC voltage. V equal to V naught sine omega t. That means omega is 100 pi. So if you are substituting that value here, pi gets cancelled. So you can see that L omega is how much? 500. L omega is 500. Yes. Okay. Then 1 by C omega. That value also you can find 1 by, what is C value? C. 50 by pi. 50 by pi micro. 50 by pi micro. Micro means 10 raised to minus 6 will come here. Into what? Omega. Omega is again 100 pi. 100 pi. So pi will be cancelled. This 100 and this 0 will become 1000 into 10 raised to minus 3. Okay. It will go up. So we get 10 raised to 3 by 5. So 1000 by 5, it is equal to how much? 200. So we got the value of what? XL and XC. Now how to find current? Our next step is finding current. So current I equal to what? I equal to V by. So you can find I naught. Here V naught is given as 140. So I naught is equal to V naught by Z. Total resistance of the circuit is the impedance. So V naught is 140 divided by impedance. You have to calculate root of R square plus L omega minus 1 by C omega the whole square. Now you know all the values. R is how much? R is given as 400. Okay. L omega we found it as 500. 1 by C omega we got it as 200. So L omega minus 1 by C omega will be 500 minus 200 will be 300. So 400 square plus 300 square. Now the calculation part I am leaving to you. You can find the value of I naught. That is peak value. But in the question they are asking what RMS value of voltage. For that we need I RMS. So after finding I naught, how can you find I RMS? I RMS is equal to I naught by root 2. find this RMS value, and after that you can substitute in these formulas. You will get the voltage across all three circuit elements. Okay, I think it is clear for you. Calculation part again I am leaving to you. You can try later. I'm going to the next. Power of an AC circuit. Another important topic, important derivation. The power, average power formula is what? Vrms IRMS into what? Cos phi. You can use this formula for any AC circuit. Vrms IRMS cos phi. Okay. What is cos phi? Phi is the phase difference here, and students, please note that cos phi is the term that is determining the power, and because of that reason this cos phi is known as the power factor. Power factor. Very important point, power factor. Tell me, what is power factor for resistor only circuit? For a resistor only circuit, what is the power factor? For a resistor only circuit, phi value is how much? Phi value is 0. Cos 0 is what? 1. So power factor is 1. It's unity for a resistor only circuit. But at the same time, for inductor only and capacitor only circuit, the power factor will be what? 0, because phi value is pi by 2. Now you have to study another formula for this power factor. In an AC circuit, you can easily see that power factor will be equal to R by Z, where R is the resistance and Z is the impedance. Okay, so please study these points. I'm going to the next. Wattless current. Wattless current. Name itself you can understand. What is wattless current? Watt is the unit of power, you know that. Wattless, no power. So a current which does not do any work in a circuit, it is called what? Wattless current. Okay, so what is the example for that? Current through an inductor, because in an inductor power factor is 0, so power will be 0. Capacitor also, the power will be 0, which means wattless current. Examples for wattless current, if they are asking, current through an inductor and current through a capacitor. Okay, so that's all about wattless current. Next, transformer. Probable 5-mark question. What is a transformer? What is its working principle? Explain the working of transformer and some sub-numerical questions. Okay, tell me. What is a transformer? It is a device which is used to increase or decrease AC, alternating voltage. Okay, alternating voltage. You can't change it using, you can't change DC using a transformer. Working principle is mutual induction, right? Mutual induction. Working, you know, there is a primary coil, there is a secondary coil. The transformer ratio, what is it? Vs by Vp is equal to Ns by Np. Vs by Vp is equal to Ns by Np. What is Vs? Secondary voltage. Vp, primary voltage. Ns, number of turns in secondary. Np is number of turns in primary. And if Is is the secondary current and Ip is the primary current, in an ideal transformer we can write this is equal to what? Ip by Is. Ip by Is. Yes or no? Ip by Is. But remember, this current relation you can take only in an ideal transformer. What is an ideal transformer? If the efficiency of a transformer is 100%, which means if there is no loss, if there is no transformer loss, we will call it as what? Ideal transformer. If it is not an ideal transformer, they will give you the efficiency value. What is efficiency? Efficiency is output power by input power. Okay, output power by input power. What is the formula for power? V into I. So output power will be what? Vs into Is, and input power will be what? Vp into Ip. So based on this formula you can find the current relation. Okay, if the transformer is not ideal. Okay, yes, clear? I'm going to the next. Okay, there is a question. Quickly, a power transmission line feeds power at 2260 volt with a current of 5 ampere to a step down transformer with its primary winding having 4000 turns. Calculate the number of turns and the current in the secondary in order to get output power at 220 volt. Easy question only. Don't make silly mistake. Transformer questions are always easy. If you're not making mistakes, silly mistakes here. So a power transmission line feeds power at 2260 volt. That means V primary input voltage is given 2260. Okay, with a current of, so IP is given as 5 ampere to a step down transformer which its primary winding, that means N number of turns in primary, is 4000 turns. Calculate the number of turns and the current in the secondary. So we have to find NS and IS to get an output power at 220. So Vs is given as how much? 220 volt. So Vp is there, Vs is there, NP is there. We have to find NS. Directly you can use transformer ratio. What is it? Vs by Vp is equal to NS by NP, and from this you can easily find the value of NS. Okay, calculation part I am leaving to you. And the second question is for finding what? Current in secondary. Here, if you are reading this question, you can see that they did not say anything about the efficiency, and they did not say anything about the loss of transformer also, which means you can consider it as an ideal transformer. So you can use the relation V by Vp is equal to Ip by Is and find the current in secondary. Okay, if efficiency is given, as I told you in the previous slide, you have to use the formula for efficiency for finding the current. Okay, yes, yeah. Okay, so I'm going to the next. Time is not there, right? So that's all about alternating current chapter. Now we are in optics, ray optics and optical instruments. You know how lengthy this chapter is. I hope you are okay with all the derivations in it. Surely one 5-mark question we can expect from this chapter. Okay, lens makers formula, so many are there. So let's quickly go through this. Right, first one is reflection of light. Okay, what is reflection of light? You know that the phenomenon of bouncing back of light when it falls on a smooth surface. Okay, so there is nothing to say about it, and just loss of reflection. What is loss of reflection? I is equal to R. Angle of incidence is equal to angle of reflection. But please note that what is angle of incidence? I is the angle between incident ray and normal. R is the angle between reflected ray and normal to the point of incidence. Okay, right. Next, spherical mirrors. There are two type of mirrors, spherical mirrors, concave and convex. There are some basic terms. You are okay with that, I think. Center of curvature, radius of curvature, pole, principal axis, principal focus, focal length. I think everything is fine. And there is a relation between, see, this is a concave mirror. It is a concave mirror, and this is the center. This distance is R, and focal length, this is the focus, this distance is the focal length. What is the relation between R and F? What is the relation between radius and focal length? Focal length F is equal to R by 2, or R is equal to what? 2F. R is equal to 2F, and the same relation you can use in convex mirror also. But please note that for a concave mirror, sign convention. For a concave mirror, focal length is negative, and for a convex mirror, focal length is positive. Okay, I think spherical mirror part is clear for you. Okay, yes. Next, mirror formula and magnification. What is mirror formula? Mirror formula is a formula which is relating what? Object distance, image distance, and focal length, right? So all of you know it because you're studying it in 10th grade also. So 1 by F is equal to what? 1 by U plus 1 by V. This is mirror formula. There may be numerical based on this. Please practice kind of questions. So 1 by F is equal to 1 by U plus 1 by V is mirror formula. And magnification. What is magnification? Magnification is the ratio of height of image to the height of object. Yes, HI by HO, height of image to the height of object, HI by HO, and you can prove that it is equal to minus V by U, because if object distance and image distance are given, based on that also you can find what? Magnification. So minus V by U. Please study this. Next, refraction of light. Refraction, core topic of this chapter. What is diffraction? It is a phenomenon of bending of light. When light travels from one medium to another medium obliquely is called what? Refraction. You know the different cases of refraction. If light ray travels from rarer medium to denser medium, it bends towards the normal. If it is traveling from denser to rarer, it bends away from normal. And in this you have to study the idea of refractive index. Very important concept. Refractive index, N is equal to, what is refractive index? It is a ratio of speed of light in vacuum to the speed of light in that medium. So N is equal to what? C by V. It is a number. It is just a number that will give you the idea about speed of light in a medium. isn't it? Yes. So more the refractive index, less the speed of light. Please note that refractive index is inversely proportional to what? Velocity. Okay, and you have to study one more relation about refractive index. Refractive index and wavelength of light are also what? Inversely proportional. That is an idea in wave optics chapter, but anyway, that's important. When refractive index increases, wavelength decreases. So please note these 2 points. Okay, next. Snell's law of refraction. I think you're okay with that statement. Please study. It states that the ratio of sine of the angle of incidence to the sine of the angle of refraction is a constant. And what is the value of that constant? Sin I by sin R is equal to N2 by N1. Not only for the statement, numerical also we need this. Sin I by sin R is equal to N2 by N1, where N2 is the refractive index of second medium, N1 is the refractive index of first medium. Okay, right. Snell's law of reflection. Next, total internal reflection. Important topic, total internal reflection. Okay, listen, what is total internal reflection? You know that when a ray of light is traveling from denser medium to rarer medium, it bends away from the normal, and all of you know that when I increases, angle of incidence increases, angle of refraction also increases. So if you keep on increasing the angle of incidence, you can see an interesting case. What is that? At a particular angle, R value become 90. So if this is a surface separating two media and this is the incident ray, means at a particular value of angle of incidence, refracted ray will be going like this. That means R is equal to 90 degree. Then the value of angle of incidence is called what? Critical angle. Okay, critical angle. If angle of incidence is greater than critical angle, what happens? The ray will be bouncing back, reflecting back to the same medium, obeying the laws of reflection. This phenomenon is called what? Total internal reflection. So my dear students, there are questions. What are the conditions for TIR? All of you know that. What are the conditions? It should, ray of light should travel from which medium to which medium? Denser medium to rarer medium, isn't it? Yes. And the second condition is what? Angle of incidence must be greater than the critical angle. So please note this point, and there is a formula as well. What is the formula? Formula is, basic formula is this one, 1 by sin C. 1 by sin C. What is C here? C is critical angle. 1 by sin C is equal to N. N means, please note that, where N is the refractive index of denser medium, ND. Okay, so this formula you can use if the other medium is air. 1 by sin C is equal to ND you can use if the other medium is air. Air means, what is the refractive index of air? It is 1. If it is not air, you have to write like this, NR, ND by NR. What is NR? Refractive index of rarer medium. ND is refractive index of denser medium. NR is refractive index of rarer medium. Okay, so you have to read the question carefully. You have to check which are the mediums. If it is like some liquid and some glass or something, means don't put the air concept here. You have to use this formula. 1 by sin C is equal to ND by NR. I think it's clear. I'm going to the next. Refraction at a spherical surface. My dear student, direct derivation will come. Okay, refraction at a spherical surface. If it is a spherical surface having a radius R and an object is kept in front of it at a distance U, it will form an image at some distance. This is the image distance is V, and this is the radius. What is the relation between N1 and N2? What is N1? First medium, refractive index of first medium. N2 is the refractive index of second medium. What is the relation between N1, N2, U, V and R? Okay, what is it? N2 by V minus N1 by U is equal to N2 minus N1 by R. N2 minus N1 by R. This is the relation between U, V, R, N1 and N2. Direct question may come. Okay, so please study the derivation. By heart the formula. Okay, by heart the formula. This formula is very, very important for our next topic. What is that? Most important topic, most important derivation of this chapter, lens maker's formula. Not only the derivation, there are scope for asking numerical questions from also from this lens maker's formula. I think all of you studied this derivation. What is our final formula? How we are deriving lens maker's formula? The starting step is this formula only. Based on this formula only we are deriving what? Lens makers. And what is lens makers formula? Tell me. 1 by f is equal to, where f is the focal length of the lens, 1 by f is equal to n2 by n1 minus 1 into 1 by r1 minus 1 by r2. 1 by r1 minus 1 by r2. Okay, n1 is refractive. For example, look, I am taking a medium here. I mean, it's a lens. n1 is refractive index of the medium in which the lens is placing, and n2 is the refractive index of the material of the lens. Okay, r1 is the radius of the first phase and r2 is the radius of curvature of the second phase. F is the focal length. One mistake that students are making when doing numerical using lens maker's formula is from the sign of radius r1 and r2. My dear students, look at this diagram. You can see that this is a double convex lens, which means both the sides are convex. So r1 is the radius of left side and r2 is the radius of the right side. Please note that if this is the lens, what is the sign of r1? Is it positive or negative? What is the sign of r2? If this is the shape, if you are looking from left side, the sign of r is positive. Okay, if the shape is like this, the sign of r is negative. I think it's clear. So the significance of this sign is, if a concave lens is given, what you can see, r1 is this one. Okay, so look at the shape. First side is this shape. So what is the sign of r1 in that? It is negative. So r1 is negative for a concave lens and r2 is what? Positive. R1 is negative and R2 is positive. So sign idea is very important, and refractive index also you need to be careful. There will be questions like the lens is kept in water. In air means, if the lens is in air, you can take N1 as what? 1 and N2 as the refractive index of the lens. In water means N1 will be refractive index of the water. So, or any other liquid they will ask. Okay, so I think this derivation and the related ideas are clear for you. Yeah, lens formula and magnification. Again, like lens formula, you know that. What is lens formula? It's a formula relating U, V and F. So 1 by F is equal to, what is lens formula? It is 1 by V minus 1 by U. Okay, 1 by V minus, while writing this formula, please go through the image formation part of all the optical devices like lens, mirror. Okay, some questions may be there to draw the ray diagram and all. So practice some ray diagram part. Okay, and the sign convention is also, my dear students, please don't make mistake in taking the sign of U, V, F and all. Concave, lens or mirror, focal length is negative. Convex, lens or mirror, no matter, focal length is positive. Concave means focal length is negative. Convex means it is positive. Okay, other sign also you should be careful, right? And what is magnification formula? M is equal to HI by HO, again height of image to the height of object, and you can easily prove that it is equal to V by U. V by U. Okay, next. Power of a lens, easy topic. What does mean by power? Power is the ability to converge the light. Okay, and here the formula of power only we have to focus. Power of a lens is equal to 1 by F. Reciprocal of focal length is the method of calculating power. So formula for power. Okay, unit of power is diopter. It is meter inverse. So when we are calculating power, please convert focal length. If it is given in centimeter, convert into meter and find it. Okay. Right, next, combination of lenses. So I'm quickly going through the topics. So lens 1, lens 2, if you are combining, this is focal length f1, this is focal length f2. What is the focal length of the combination? How can we find? It is 1 by f is equal to 1 by f1 plus 1 by f2 if there are more lenses plus etc. plus etc. 1 by f is equal to 1 by f1 plus 1 by f2 plus etc. Okay, and power of the combination P equal to what? P1 plus P2 plus P3 plus etc. But my dear students, again in this topic, be careful about the sign. If in a question it is given that one convex lens is combined with a concave lens, then focal length of convex is positive, concave is negative. So don't forget to substitute the proper sign. Okay, so I think this part is also clear for you. Yes. Prism, refraction through a prism. Another probable 5-mark question, the derivation. Okay, so what we are finding in refraction through a prism, we are finding the expression for the refractive index of the material of the prism. Refractive index. Okay. Flip-flop. It is, we are studying in optical instruments that how to find, if they are not in contact, how to find the magnification and focal length and all. Focal length is fixed. You have to find the magnification separately and substitute. Okay? Right. Refraction through a prism. In refraction through a prism, you know that this is the arrangement. Okay, this is the base of the prism, incident ray is falling like this is the angle of the prism. Okay, yes. What is the final formula? Final formula is refractive index n is equal to sine a plus d by 2 by what? Sine a by 2. Sine a plus 2 by a plus d by 2 by sine a by 2. What is d here? D is the angle of minimum deviation. So you should have an idea about, when you are studying the formula, that picture should be there in your mind. Which angle is d? Which angle is a? Which is I? Which is e? Everything should be there. So please study the proper diagram. This is the direction of incident ray. The ray is undergoing refraction. This is a normal to the first medium. This is a normal to the second phase. The ray is coming out. This angle is angle of deviation. This is our I. This is our angle of emergence. This angle is A. Okay, and while studying this derivation, you have to study some more formulas that will help you in doing numerical. Okay, what is it? Relation between angle of the prism and R1 and R2. This angle is R1 and this angle is R2. So A is equal to what? R1 plus R2. Another formula. Okay, and the next one is deviation. Deviation formula is I plus E minus A. So please keep these formulas also in your mind, then you can do all the numerical based on prism, if you have idea about these things. So hope you understand the difference between small letter d and capital D. Small letter d is the angle of deviation, but capital D is minimum deviation. Okay, right. So I'm going to the next topic. Question. Okay, find the position of the image formed by the lens combination given in the figure. Okay, I'll just give you the idea. What you can see, there are three lenses. The first one is a convex lens, then there is a plano concave lens, and finally there is again a convex lens. The separation between the lenses are given. First lens and second lens are separated by a distance of 5 cm. Second and third are separated by 10 cm. Focal length of all the lenses are given. Okay, what you have to do is start with the first lens. What's the first lens? L1 we can name. For L1, focal length is given. Focal length of first lens is given as 10 cm. It is a convex lens, it is plus. And object is kept in front of that lens at what distance? 30 cm. So U, object distance is 30 cm. But what is the sign of that? It is in front of the lens. So U is negative. Yes. I don't know the name, that I can see like gaming. Graffiti, yeah, that's correct only. Okay, image formed by the first lens will be behaving like object for the second lens and go on. That's the trick of this, but you need to be very careful about the sign. Okay, so using this you can find V value. Okay, so let's calculate V using lens formula. 1 by F is equal to 1 by V minus 1 by U, which means 1 by V is equal to 1 by F plus 1 by U. So let us substitute it. 1 by F is 10, U is negative, so we get minus 1 by 30. So you can take 30 as LCM. So we get 3 minus 1. So 1 by V is equal to 2 by 30. V is equal to 15 centimeter. 15 centimeter is the image distance for the first lens. Is that idea clear? Which means from the first lens, please note that from the first lens, the image is formed at a distance of 15 centimeter, and we are getting it as plus 15, which means surely the image is formed on the right side of the lens from here at a distance of 15 centimeter. That idea is clear now? Now that image, that means at 15 centimeter an image is formed. That image will act as an object for the second lens. So when we are talking about the second lens L2, what is the object distance? See, 15 centimeter. So from this lens, from first lens, it is formed at a distance of 15 centimeter, but the first lens and second lens are separated by 5 centimeter, means the object distance will be how many centimeter? Yes, object distance will be 10. You can see that the image is at a distance of 10 centimeter from the second lens, and it is on the right side. Right side means for the second lens, what will be the sign of object distance? Sign of object distance, U will be positive 10 centimeter. 10 centimeter. Is it clear? Yes. And what is the focal length of the lens? Interestingly, the focal length of that lens is also 10 centimeter, which means object is at focus. Object is at focus means image will be at infinity. Done. We got the final answer. We can easily find. Second lens will form the image at infinity. That image only will act as an object for the third lens. Got the point? So for the third lens, where is the object? Object is at infinity. If object is at infinity, where will be the image? Quickly. If object is at infinity, image will be at, yes, image will be formed at focus. Focus of the third lens. So what is our final answer? Focus of the third lens is 30 centimeter, right? Which means the final image will be formed at a distance of 30 centimeter from the third lens. I think you got the idea how to approach these kind of questions. Start right from the first lens. Check the object distance, focus, find the image distance, that image distance, from that image distance find the object distance for the second lens, and go on. I think it's very clear. Okay, yes. Flip-flop, yes, it will be 30 plus 30 only, that you can substitute, you will get in the mirror formula. Okay, I mean lens formula. Next is again a question of double convex lenses. Double convex lens means both sides are convex, are to be manufactured from a glass of refractive index 1.55 with both faces to the same radius of curvature. What is the radius of curvature required if the focal length to be 20 centimeter? It's an easy question. See, required focal length is given as, focal length f is equal to 20 centimeter. So f is given as 20 centimeter. Okay, refractive index is given as 1.55. They are asking what is a radius of curvature, and it is given that both faces of the same radius. Okay, so both are same means, see, if this is a lens, 1 by f is equal to, here they did not say about the first medium, so you can take it as air. So n2 by n1 means simply n2 only. So n2 minus 1 into what? 1 by r1 minus 1 by r2. 1 by r1 minus 1 by r2. So 1 by focal length is 20 centimeter equal to 1.55 minus 1 into, what is the sign of R1? I hope all of you remember. What is the sign of R1? Is it positive or negative? Sign of R1. R1 is positive, but R2 is negative. So we get minus, so 2 by R. Now the calculation is easy. Okay, calculation part I am leaving to you. So based on the question, please, once again I am telling you, be careful about the sign. Okay, next question. Yeah, this is a repeating question, you can see in many papers. 3 light rays, red, green and blue, are incident on a right angled prism ABC at face AB. The refractive indices of the material of the prism for red, green and blue wavelengths are 1.39, 1.44 and 1.47 respectively. Out of the three, which color ray will emerge out of the face AC? Justify your answer. Trace the path of these rays after passing through the face AB. Okay, here it is given like colors. In some question you can see instead of colors they will give some numbers only, 1 2 3 or 1 2 like that, and you have to trace the rays, you have to draw the ray diagram, and you have to justify your answer as well. Okay, actually you may think that this is a question based on prism. Actually it is not a question based on the prism part which we studied. It is a question based on critical angle. Critical angle based question is this. So why the question is based on critical angle means you can see that, yeah, you have to check which one will undergo TIR. Very good. See, there are three colors, and the first phase, the phase AB, you can see they are perpendicular to all three colors. So perpendicular means you know what will happen to the ray. The ray will go straight only. Without any deviation the ray will go. So how can you draw? First ray will go like this. We can take colors itself directly. Blue, right? This is blue, so blue color is going like this, and then green is going like this, and red is going like this. All the colors are going like this. Okay, and when it reaches at the second phase, they are not perpendicular. So our next step is finding the angle of incidence. It's very easy. If you are drawing normal, this is a normal, right? It's an isosceles right angle prism. So this angle is 45, this is 45, this is 90. So this will be 45, this will also be 45. So angle of incidence for all the colors is what? 45 degree. I equal to what? 45 degree. That is the first point. We got angle of incidence is what? 45 degree. Is it okay? Angle of incidence is 45 degree. Now what we have to check? We have to check the critical angle. If the critical angle is less than 45 degree, for example, the critical angle is 43 degrees, assume. If critical angle is 43, I is 45, which means angle of incidence is greater than critical angle. Rays will undergo what? TIR. That means instead of going out, it will be reflected back. I mean 90 degree reflection will be there. It will be reflected down at the same angle of incidence. So what we have to check in this question is what are the values of critical angle for each colors. What is the critical angle for blue? What is the critical angle for green? What is the critical angle for R? Is it greater than 45 or less than 45? But how can we find that? We have refractive index with us. 1.39, 1.44, 1.47 are the refractive index for the different colors. Let us take our angle of incidence is how much? 45 degree, right? What is the relation between refractive index and critical angle? N is equal to 1 by sine C. N is equal to 1 by sine C. My dear students, please note that refractive index and critical angle are inversely related. That means more the critical angle, less the refractive index. That point is clear? More the value of critical angle, less the value of refractive index. Now, let us assume the critical angle is 45. Just assume critical angle is 45. So, what will be the refractive index for 45 degree? N for 45 degree, okay, will be equal to 1 by sine 45. Okay, what is sine 45? Sine 45, you know that it is 1 by root 2. 1 by root 2 means this root 2 will go up. So we get n is equal to root 2. Root 2 is equal to 1.41. Yes or no? 1.41 is the refractive index if the critical angle is how many degree? 45 degree. Understood or not? So if critical angle, if C is equal to 45, if C is equal to 45, the corresponding refractive index is how much? 1.41. If C is equal to 45, N is equal to 1.41. My dear students, please note that refractive index and critical angle are inversely related. That means if n is greater than 1.41, if n is greater than 1.41, what we can say, critical angle will be less than 45 degree. Critical angle will be less than 45 degree. Got the point or not? So check the colors. Refractive index 1.39, 1.44, 1.47, which means we can easily pick for 1.44, 1.47. Both are greater than 1.41. What does it mean? Their critical angle value is less than 45 degree. Got it or not? So our angle of incidence is 45, but for these two colors 1.44 and 1.47, angle of incidence is greater than what? Critical angle. Which means what will happen here? Those two colors will undergo TIR. Which all colors? The order is green. First one is red, then green, then blue. So 1.44 is for green and 1.47 is for what? Blue. So green and blue will undergo TIR. Yes or no? So blue will come down, green will come down. But what about red? For red color it is 1.39. Refractive index is 1.39. So if n is less than 1.39, what does it mean? C will be greater than 45 degree, which means angle of incidence is less than critical angle. Less than critical angle means it will not undergo TIR. It will go out like this. Yes, that is the answer. Clear or not? Is it okay? Please comment, is it clear or not? How to find the answer here? Can I go to the next? Yes. So next is optical instruments. I'll quickly go through it. Please, first thing I need to tell you, please study all the ray diagrams properly. Okay. Practice it with a scale pencil by taking proper measurement, image formation, everything make perfect. First one is simple microscope. By heart the formula for the magnification. Simple microscope, we have two cases. Image is formed at near point and image is formed at infinity. For a simple microscope, if image is formed at near point, what is the magnification formula? M is equal to 1 plus D by F. If the image is formed at near point means least distance of distinct vision. 1 plus D by F. What is D? D is the near point, which means least distance of distinct vision. And if image is formed at infinity, it is D by F. D by F. Okay. Please study the ray diagram. Next, compound microscope. Compound microscope, there are two cases again. Image is formed at near point, image is formed at infinity. So magnification basic formula you can see, it is MO into what? ME. MO into ME. MO is magnification produced by objective. You know there are two lenses, objective lens and eyepiece. So there are different formulas. VO by UO into ME is, if it is at near point, it is 1 plus D by FE. Okay, or this can be written as L by FO into 1 plus D by FE. What is L? L is the distance between the second focus of objective to the first focus of what? Eyepiece. Okay, and in the other case, that means if the image is formed at infinity, same way, VO by UO into 1 plus D by FE, or we can write it as L by FO into what? D by FE. D by FE, and all magnifications are negative. That also you have to consider because we are getting inverted images. Okay? Yeah. Yes, derivations are important Adil, because you know there is chance of asking. Vigneshwaran, I don't have any problem for drawing the diagram of microscope, but the problem is time. Okay, it is there in the reader. No, yes it is, you can study. Okay, yes. No, derivation you have to study. But by heart the formula, because you know if they are asking the derivation of these questions, like diagram will carry around 2 marks if need diagram means, and only few steps are there. So by hearting the final formula means you can cut the steps and write the final formula. Okay, you can score almost full mark from that. Okay, right. Yes. And next is Telescope. Telescope is again in your reader, if you are checking textbook, only one derivation is on, but the other case also formula you have to study. Okay, so diagram is like if object is at infinity, image is also formed at infinity. What is the formula for magnification? It's an easy formula. It is f4 by fe. If the final image is formed at infinity, f4 by fe. Okay. Yes, and then if it is formed at near point, the formula is f4 by fe into 1 plus fe by d. If the final image is formed at near point, you have to use the second formula, and if it is formed at infinity, the first formula. Once again, optical instruments is important. Go through the reader, study the diagrams. Okay, and there is one more reflecting type telescope, Cassegrain telescope. You know it. There may be questions like what are the advantages of reflecting type telescope over refracting type. That's a repeating question. There is no problem of spherical aberration, no problem of chromatic aberration, easy to handle. So many advantages are there. Okay, yes, right. So I'm going to the next. There is a question, numerical we can do from optical instrument. Checked it. A compound microscope uses objective lens of focal length 4 cm and eyepiece lens of focal length 10 cm. An object is placed at 6 cm from the objective lens. Calculate the magnifying power of compound microscope. Also calculate the length of the microscope. Question is direct, but they did not mention which case it is. Whether the final image is formed at infinity or final image is formed at near point. Okay, so it's our choice. You can take any case. So I'll be doing the case where the image is formed at the near point. Okay, so image is formed at the near point means the formula is m is equal to VO by UO into what? 1 plus D by FE. This is the formula for finding what? Magnification. Now check the question. Use as an objective lens. So of focal length 4 cm means FO is equal to 4 cm. You know that, or all are convex lens, so sign will be positive. Okay, 4 cm. And eyepiece FE is given, leave it. Object is placed at a distance of 6 cm from the objective. So U of objective is given as 6, but please note that it will be negative, because we are placing it in front of the lens. Okay, and using lens formula you can find what? VO. Okay, substitute it, you will get the answer. Okay, calculation part I am leaving to you. What is the value of D? D will be 25 centimeter focal length of eyepiece is given. Is it okay? Right. Now there is another question. Please don't mistake it. Also calculate the length of the microscope. How can you find the length of the microscope? See, if any numerical is asking from optical instruments, please don't go directly with the formula, because you know that there are different formulas, different cases. Okay, so for example, length of the microscope means, length of the microscope, you know that it is the distance between objective and eyepiece. So just draw Vigneshwaran, no, what I said is convex means mirror or lens. Convex means focal length is positive. Concave means mirror or lens, it is negative. Fix it. Concave is negative, convex is what? Positive. Okay, yes. So length of the microscope means it is the distance between objective and eyepiece. Objective and eyepiece. So here what you have to do is, like if you are keeping an object here, it will form an image. For example, image is formed here. That image only is acting as what? Object for the eyepiece. So if this distance is x and this distance is y, the length of the microscope is x plus y. So what you can see here is x is nothing but VO, image distance of objective. That VO already we found in this calculation. You can find what? VO value. Then this one is the object distance for, it is the image distance for, image distance for objective, and this y is object distance of eyepiece, but that value we don't know. Understood? This is the reason why I told you to draw a rough diagram in numerical part. Then you will get an idea. So here what we have to find is VO plus length of the microscope is equal to VO plus UE. That's what you have to do. The second part of the question. Okay? Yes. Now how to find UE value? For UE, it is the object distance of the eyepiece. So take the eyepiece. For the eyepiece, focal length is given FE. Check that. Focal length of the eyepiece is 10 centimeter. And what is the image distance of the eyepiece? Image is formed at near point 25 centimeter, but it is negative in front of, so minus 25. You can easily find what? UE, object distance. Find object distance UE using lens formula, substitute in it, you will get the answer. Understood or not? So again I am telling you, optical instruments, please don't go ahead with some formulas which you know. Understand the situation clearly, draw rough diagrams, check what is they are asking, substitute the proper formula, and sign also is very important. Okay, going to the next. Wave optics, the last chapter. Wave optics, one advantage is there, like some topics are deleted, some derivations are not there, so concentrate on the formulas only. Okay, wavefront, probable question, MCQ like that. What is a wavefront? You know that it is a locus of all particles or points which are vibrating in what? Same phase. Is wavefront. Yes or no? Yes. Then shapes of wavefront. Very important. What are the probable shapes of wavefront? Yes, total magnification will be always negative, Adil. Okay? Listen. Wavefront shape. If there is a point source of light, what is the shape of the wavefront? It is spherical. If source is at infinity, it will be plane. If line source means it will be cylindrical, like that. Okay? You can load of biology, I don't know what CBSE Board. You can draw in your answer sheet itself. Okay, right, no problem. Yeah. So about wavefront, an important point which you have to notice: a wavefront is always perpendicular to the ray. A wavefront is always perpendicular to the ray. There will be questions like, if a point source is kept at the focus of a convex lens, a point source is kept at the focus of a convex lens, draw the emerging wavefront or draw the wavefront coming out of the lens. What will be the shape? It will be ray diagram. If you are drawing, you can see that the rays will be like this. If object is at focus, the image will be at infinity, you know that. That means the refracted rays will be like this. So what will be the shape of the wavefront? The shape of the wavefront will be perpendicular to those rays. It will be a plane wavefront. Okay, so like this you can draw. So like that, there is chance of asking the shape of wavefront questions, my dear students. Next topic is Huygens principle. There are two principles. There won't be any confusing question. Directly they are asking straight Huygens principle. The first one is, every point on a wavefront will be behaving like a fresh source of light which is emitting light in forward direction. And second one is, the surface tangential to the secondary wavelets at any instant gives the position of a new wavefront at that point. So please study Huygens principle. Next is, yeah, this is a probable 5-mark question. Prove law of reflection and refraction by using wave theory. So law of reflection and refraction means you have to prove I equal to R using wave theory. And number 2, law of reflection, Snell's law. That means sin I by sin R is equal to N2 by N1 using wave theory. That also you have to prove. It's a direct derivation. Please study it. Okay. Next. Interference of light, core topic of this chapter. 1 or 2 question is sure from interference. Okay, most probably an application type or a numerical. What is interference? You know that definition of interference of light is, it is a phenomenon of redistribution of light energy due to the superposition of 2 or more waves. Phenomenon of redistribution of light energy due to the superposition of 2 or more waves is called what? Interference of light. Okay, energy is getting redistributed. Right, so superposition principle, you know that resultant displacement y equal to y1 plus y2 plus y3 plus etc. Okay, in interference the main topic is, as you know, Young's double slit experiment. Young's double slit experiment, what is it? In this setup, you know that there is a point source of light and there are two narrow slits S1 and S2 kept at equidistant from these slits, and there is a screen. On the screen you can see alternate bright and dark bands with a bright band at the center. That center we will call the maximum band, central maxima, right? Okay, now what are the things you have to study about Young's double slit experiment? There are many things. First thing is, what are the conditions for getting a repeating question? What are the conditions for producing sustained interference pattern? It's a repeating question. Sustained interference pattern we need. First one is, we have to use coherent sources of light. I think you know what are coherent sources. If two sources of light are emitting light with same frequency, zero phase difference or constant phase difference, they are called coherent source of light. So we must use coherent source of light. That's the first thing. And number two, the source of light should continuously emit light. There should not be any kind of destruction there. It should continuously emit. These are the conditions for getting sustained interference pattern. Okay, then the next thing is, what about the intensity? Intensity formula you have to by heart, you have to study. Okay, if I naught is the intensity of light coming from this, I naught is the intensity of light coming from this, then the resultant intensity formula is I equal to 4 I naught cos square phi by 2. This is the formula. This is very important. Cos square phi by 2. What is phi? Phi is the phase difference between the lights. Phase difference between the lights reaching a point. My dear students, another important concept, relation between phase difference and path difference. Without that idea, you can't do numerical based on YDSC. What is the relation between phase difference and path difference? It's very easy actually. Listen, first of all, you should understand what is the meaning of path difference. From the name itself, you can understand path difference means, from the name itself, it is clear, difference in path. See, look at this line. From the diagram, clearly you can see that the distance S1P and S2P are equal. S1P is equal to S2P. So what is the difference in distance? 0. So that distance is called the path difference. So path difference is what? 0. Okay. If path difference is 0, phase difference will also be what? 0. Same phase. Got it? But it is not 0 in all the cases. If it is not 0, how can you find the relation? The relation is simple. If path difference between two waves is lambda, then their corresponding phase difference will be 2 pi. Study now itself. If lambda is the path difference, phase difference is what? 2 pi. Then you can find anything. If path difference is x, then phase difference will be 2 pi by lambda into x. Using this relation, you can find all the path difference and phase difference. Is it clear or not? Now, in this equation, intensity formula, once again, you can see that I max, maximum intensity will be how much? 4 I naught. Because for it to be maximum, cos function should be maximum. So we get 4 I naught. That means that is the intensity of the bright fringe in interference pattern. And what is I minimum? I minimum is 0. That means 0 energy, perfect dark. Okay, yes. Now, if you are taking some other point, look at this point. If you are taking that point as P dash, surely from the diagram you can see that the distances are not equal. Distances are not equal means there is a path difference. If there is a path difference, surely there will be a phase difference. Then what, how can you find that point? Will it be bright or dark? That's another important idea you should have. So this point P dash, if for it to be bright, hope you remember the condition. What is the condition? For it to be bright, the path difference is equal to n lambda, where n is equal to 0, 1, 2, 3, etc. integers, which means if the path difference is an integral multiple of lambda, that point will be bright. And at the same time, for it to be dark, the condition is path difference is equal to 2n minus 1 into lambda by 2. 2n minus 1 into lambda by 2. Where n is equal to 1, 2, 3, etc. 1, 2, 3, etc. These conditions are also very important conditions for bright and dark. Bright and dark. Okay, yes. Now, one more formula you should study from it. That is, this is a central maxima. The point P is the central bright, and this is any point if you are taking this point as x. X. We have a formula for x. That is, x is equal to d by d into path difference. This is also very important in solving numerical. D by d into path difference. What is capital D here? Capital D is the distance between the slit and the screen. D, capital D. And what is small d? Small d is the distance between two slits. So d by d into what? Path difference. Why this formula is important means if you are checking the past year questions, you can see that calculate the distance of the third bright fringe from the central maxima. Third bright from the central maxima. So what you can do, x is equal to d by d, path difference, third bright. What is the path difference for bright? Bright is n lambda. So for path difference, you can put n lambda and take n is equal to third bright means 3. Like that you can find the distance. Hope it is very clear for you. Yes. Before starting diffraction, there is one more topic, fringe width formula. Beta is equal to fringe width. Beta is equal to lambda capital D by small d. Okay, beta, there are plenty of numerical expecting from this formula. Fringe width, all fringes are having the same width, so there is no confusion. Find the width of the third bright, find the width of the fourth dark, no need of any confusion. All the fringes are having the same width, lambda d by d. Understood? Yes. So next is what? Diffraction of light. Diffraction, there is no complicated derivations or something, only the final idea. First, what is diffraction? It is a phenomenon of bending of light around the edges or corners of an obstacle. Edges or corners of an obstacle. Okay. That is called diffraction. Now we have diffraction at a single slit. In a single slit diffraction pattern, like if this is a slit on the screen, if there is a source of light on the screen, you can see alternate bright and dark rings with a bright spot at the center. At the center there will be a bright spot, and that is called central maxima. So this is central maxima. Its intensity will be very high, but it is covered by some dark rings and some bright rings, but the bright rings, you can see their intensities are keep on decreasing, and those rings are called secondary maximas. Secondary maximas. And what you have to study is the condition for what? Secondary maxima. For condition for secondary maxima is, you can just think like this. The condition for minima and maxima in interference and diffraction are reverse. That means the condition for maxima in diffraction is the condition for minima in interference. So what we can write is, from secondary maxima it is 2n plus 1 into lambda by 2. Please note that it is 2n plus 1. The previous one we took it as 2n minus 1. Okay, why means here if you are substituting n is equal to 1, we get 3 lambda by 2, which means the first secondary maxima is obtained at 3 by 2 lambda. That's the reason why we are taking it as 2n plus 1. Okay, then another point, if it is secondary minima, minima means dark, secondary minima, what is the condition? The condition for minima is path difference is equal to 2n minus 1 into what? Sorry, condition for minima in diffraction is condition for bright and interference. That means path difference is equal to what? To n lambda. Path difference is n lambda. Okay, please study this. And another thing is, how can you find path difference? Path difference in this case means path difference is equal to, there is a formula for path difference. Path difference is equal to a sin theta A sin theta. What is A in it? A is the width of the slit. Okay, and theta is angle of diffraction. Angle of diffraction means through how much angle this ray is bending. Through how much angle the ray is bending, that's called angle of diffraction. So please note that if this is the slit and the light is going straight like this, and if it is bending in this way, this angle is called what? The angle of diffraction. Okay, so path difference is A sin theta means for dark, what is the condition? A sin theta is equal to n lambda. For bright, what we can write? A sin theta is equal to 2n minus 1 into what? Sorry, 2n plus 1 into lambda by 2. So please study this. And we have one more formula in it, that is width of central maxima. Width of central maxima, numerical will come. Width of central maxima will be 2 lambda d by A. This is the formula for what? Width of central maxima, 2 lambda d by A. And they may ask angular width also. Angular width. So angular width is, hope you know what is the meaning of this angular width. That means central maxima is making how much angle with the slit. So angular width formula is 2 lambda by A only. So what you can see here is angular width is independent of what? Capital D. Independent of capital D. Okay. So there will be questions like probably MCQ, if the distance between the slit and the screen is doubled, what will happen to the angular width? Nothing will happen because it is independent of capital D. I think the theory part is fine, and time is also running in short. It is closed 9:30 now. So some questions are there, you can just check. You can watch this video later also, try to do this question. Okay. When two narrow slits 2 mm apart are illuminated by white light of wavelength 5000 Armstrong, the third minima is measured to be 0.5 mm from the central maxima on a screen. What is the distance of the screen from the slit? So they are asking us to find capital D, and please note that the third minima is measured to be 0.5 mm from the central maxima. I told you, distance from center maxima to third minima, x is equal to, x is given as 0.5 mm. And it is third minima. Minima means, you know the condition for minima, right? So what is the formula for x? X is equal to d by d into what? Path difference. D by d into path difference. So d by d into, for minima, the path difference is 2n minus 1 into lambda by 2. And put n is equal to 3 because it is the third minima. X is given, small letter d is given, it is 2 mm. All data are there, wavelength is also given. You can easily find what? The value of capital D. So you can try it. Next, in Young's double slit experiment, width of the fringes obtained with a light of wavelength 6000 Armstrong is 2 mm. So when wavelength lambda is used, beta is how much? 2 mm. 2 mm. What will be the fringe width if the apparatus is immersed in a liquid of refractive index 4/3? 4/3. So don't be confused. We know that beta formula is what? Beta is equal to lambda d by d. Lambda d by d. I told you the relation between lambda and refractive indexes, they are inversely proportional. They are inversely proportional. So here you can write beta is directly proportional to lambda, which means beta is inversely proportional to the refractive index, inversely proportional to n. So what we can write? Beta 1 by beta 2. Beta 1 by beta 2, since they are inversely proportional, it will be n2 by n1. So beta 2, new fringe width, will be equal to what? n1 by n2 into what? Beta 1. Okay, so n1 by n2, n1 is 1 only, n2 is given 4/3, beta 1 is given. You can substitute and find the answer. Okay, right. Now next, the light of wavelength 600 nanometer is incident normally on a slit of width 3 mm. Calculate the linear width of central maxima when the screen is 3 meter away from the slit. Okay, linear width of central, not the angular width, linear width only they are asking. So we have a formula. What is it? 2 lambda d by A. Everything is given. Lambda is 600 nanometer, D is 3 meter, A is 3 millimeter. Substitute and you can find the answer. Okay. Yes, that's all. I know it was a very quick session. We did not get time to explain each and every point, but my dear students, by this session we are winding up the revision, the rapid revision program of physics. I told you the importance of tomorrow. Tomorrow is the last day for us to prepare. I need to make some important points that while writing exam, my dear students, please be careful. Read the question carefully. That's the first thing. You have enough time. Read each and every line of the question. Don't be excited, especially in the numeric MCQ part. MCQ answer you have to cross check, double check your answer. Okay, chance of silly mistake is very high in MCQ. Okay, so please check it. And another thing is, for derivation questions, for 3 marks, 5 mark questions and all, do write proper introduction. Okay, need diagrams, proper conclusion. Okay, your paper answer sheet should speak for you. Okay, your paper will be reaching in someone else's hands, so your paper is the only way to communicate between you and the teacher. Okay, so it should reflect your ideas, your thoughts. Like you should be able to create a feeling that okay, you are a student who know all the concepts. So in that way only you have to present your paper. All right, and brilliant group of institutions. So we have been doing this session for the last 1 month for the benefit of the students. So our prayers will be there always with you, my dear students. All the best wishes for you on behalf of brilliant group of institution. Best of luck. Thank you.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.